The bill has already been significantly reduced.
Before all that, I will introduce Nicolas and myself.
So basically, I am Bruno.
And I created Big Blue about 1.5 years ago. My friend Nicolas, who is an old friend of long standing, tested it for 1 year at Foxintelligence, where he was the chief technology officer. And Fox, they're big users of BigQuery. So we fine-tuned the tool a bit for Fox's needs for 1 year, and we opened
the public beta in the fall.
And
today, basically, we have 4 clients. Since we opened this
public version. And in all these clients, plus all the other demos we've done, so it's companies of very different sizes, with very different data types, we realized that actually it was always the same 6 things coming up that we advised doing in first as a priority to reduce costs. And these are the 6 actions we will present to you. These 6 actions, they can be implemented without our tool. These actions are directly implemented on the BigQuery console. But of course, Big Blue, we will give you a presentation of both tools each time, which will help you make decisions for implement that.
So how does it work?
Big Blue is very simple. Basically, Google BigQuery, what it does is it creates each time a table called schema information, in which it stores basically all the metadata of all the queries, of all the jobs that run on all the projects. And we request a service account to read, but only these metadata. So we never touch your data. We don't have access to it. And a small data set where we will be able to write the data we produce. And just from that, we are able to produce dashboards and analysis that will allow us to make quick decisions. So the 6 actions.
Yes, Simon, I saw that you raised your hand.
Yeah, I wanted to, sorry for the camera, I'm recovering, but the information schema, is it true for everything that happens on BigQuery, or is it true only when using the BigQuery editor? Let me explain. If typically we connected a metabase that will make queries via API, so it will use BigQuery, the BigQuery API to make its queries, it seems to me that this data doesn't go into the information schema, but that we can retrieve it via BigQuery logs, but then...
Yes, you have everything in the information schema, and you can find it because the meta batches, the lookers, etc., tend to add labels that you put on the right for your queries.
But then, yeah, they fall because I remember I had tried to look at the information schema jobs and I couldn't find, I had almost nothing, and then actually I went through the BigQuery logs directly on Google Cloud that I put into a data set and can explore.
You can, but there's a little nuance. It's the second service you're going to use for, finally, the place where you're going to make your query on the information schema. You need to do it on the multi-project. Generally, you need to do, that's what we do to gain access. It's that the second service we're going to request is at the level of the root of the organization. Because otherwise, if you're on a single project, you don't see, the rest of the other project.
Maybe that's it.
That must be it.
Yes, welcome to those who are joining. A little update, we will present the 6 actions.
It doesn't stop anymore.
We will present to you the 6 actions we consider to be the most effective. In any case, when we present our Big Blue solution to our clients, these are always the 6 priority actions that help them reduce their bill at the end of the month. I will quickly repeat what I just said. Basically, what is Big Blue? It is a software as a service that from a service account with very limited access, just to metadata written in the schema information, will allow for the production of dashboards to optimize performance and reduce costs. And once again, the actions I'm proposing don't need Big Blue to be implemented. You can implement them without our tool. Here are the 6 actions. The screen there for quite some time, so I'm moving directly to B-Engine. Like that, we save time.
What is B-Engine?
It's a feature of BigQuery that is quite powerful. Basically, it's very simple. It's RAM. It will put your data in RAM. It's RAM that we pre-reserve, so 5 gigabytes, 10 gigabytes, etc. And everything is automatic. So there is one click to make, and when the data can be processed on it. So it's not all the data. It has to be select and able to communicate. But still, a large part of the data can be processed on it. We only pay for the reservation. That means at that point, the query, the job costs nothing else but the reservation.
What's immediately apparent is that the queries are much faster since it's in RAM, so we reach more
to the hard drive, etc. And once again, it's less expensive since the entire cost of the query is reduced to zero. We only pay for the reservation, and it's completely automatic. And of course, if ever the query can't pass in this mode of B engine, it automatically falls back to on demand. So actually, it costs absolutely nothing and requires no setup. There is no code to do. I don't know if Nico, you want to show how it works on the console. It might be more illustrative. Yeah, definitely. So, okay.
If you see my screen, yes, that in 2 seconds, that's that's Big Blue. It's an interface. What you see is the page where we summarize all the optimizations we've detected. Here it's data, fake data. It's to give to show you an example. We'll start with the first one, the simplest. It's to show you how you create a BI engine instance. There, you see my BigQuery screen, all good. Okay, you go there, administration, you have BI engine. You do it on the project where there's the most stuff, people. It's still the best thing to do. You click there and you select the region where you have the data. That's important. I will do a test with that. And here you select the memory Bruno mentioned, which goes from 1 to 250. And on the right, you have the estimated monthly cost if you turn it on and leave it on all the time. Okay, the companies we've been working with now for 1.5 months, they all do a test with 4 gigabytes of memory. And to give you an idea, these are people who make 1 million requests per month and have on-demand bills ranging between 1,500 and 3,000 euros per month. You click next, leave everything by default, and that's it, you're done. So in 3 clicks, you've launched it. There, if you do it on your infrastructure, let's say it takes a little time to deploy, but in 5 to 10 minutes, the queries from your workload, from your pipeline, will start trying to enter BI engine. That's what Bruno was saying. That's it. Either it enters, succeeds, and costs you 0 in on demand. You only pay for the reservation, or it goes on demand as usual, just as you usually do. That's really something we highly recommend. It changes your life a bit, and above all, it goes much more quickly. That means your queries, instead of, let's say, a minimum duration of 2 seconds, there will be around 120 milliseconds. So even in terms of usage, you get a big performance boost.
And how do you, on the screen where you put you choose the size, how do you decide on the size?
So precisely, we can't choose that in advance.
You always have to put the max. Exactly.
Do not do that. What I recommend is to start with something a bit small like that. And then the simplest thing is to go into cloud monitoring, which is another tool from Google, where you can create dashboards. There I made one, but it's very simple. Do you see my screen with the graphs? Yes, you have 2 curves. The blue one, which is, for me, it's my earlier reservation, where we have 1 gigabyte. There, it's for last week, since we never change it, and it's always on. It's a flat line like that of 1 gigabyte. Since we don't have much use on that one, it's just for the example, we have the memory consumed. There, we can't go below 1 gigabyte, otherwise we would. Imagine you have an instance to 4 gigabytes, and then your green curve, it oscillates between 0 and 3 gigabytes. You could lower this limit to 3 gigabytes rather than 4 gigabytes. You would already save 25% of that cost. And you have the opposite case. Imagine that your green curve, it regularly peaks at the level of the... In that case, the idea is perhaps to increase BI engine's memory to see if it can capture more queries to handle even more.
If I understand correctly, what you're saying is that basically you turn it on, it's always on, and you pay at the end of the month. That's your bill if you're on it the whole time. But do I have to keep them on all the time? Can you turn them off from time to time? Does it save money or not?
Completely, but I will show you that screen. That's going to be good. Here we are in Big Blue. It's in Analyze Jobs, which is here. What you have is, over the course of today, the number of queries divided between BI engine in red and on demand in orange. This configuration, I know it. The BI engine server is only on between 7 in the morning and 7 in the evening. At night, it's off. Why? Because you see, even in the morning when it's on, the proportion of queries going into BI engine is quite low compared to on demand, simply because they are not suitable queries that are not supported by this thing. Perhaps there is a lot updates, a lot of inserts or things like that. In any case, we notice that there are no major changes. At 9 o'clock, however, it starts to take a big portion of the requests. The thing is, people start working at 9 o'clock. It's true that often it's also related to human usage. And by the way, BI engine, it was invented, I first think of it for tools like Looker or Tableau or Metabase to facilitate and speed up the latency of interfaces when you analyze dashboards. It's really very useful, and it really serves that purpose to accelerate the user experience.
Can you terraform it, that kind of thing, to say on Saturday I turn it off?
Exactly. In this case, the previous screen where we were talking about, okay, it would cost $200 a month. If you already only turn it on 12 hours a day, it's $100. If furthermore, you turn it off on the weekend, you remove 2/7 of that bill again. So there is really a way to fine tune it. The first step is to turn it on to see what it gives you. And then you are able to evaluate. And by the way, I will show you that quickly. That's another analysis called BI engine. Here you have two projects that are interesting. The first one, that's the project name that is on the instance, the memory being used. Here it's over 1 week. Here we see that the cost of the reservation is $756. This is the cost of the queries that were run if they had been billed on demand. Here we see that the reservation cost a little bit more. On the other hand, the one below, we have 100 gigabytes. So $378 for a 1 week reservation. However, the queries, if they were run on demand, would have cost $600. That's $222 per week. We're almost at $900 a month in savings by doing what? The 3 clicks we did earlier to turn on BI engine. So it obviously depends on the nature of your queries, but it is astonishingly easy. And above all, you get an incredible performance boost that can also save you money. That's really the thing to test, honestly. As soon as we finish the call, it's an essential thing. There you have it for the Big IR engine.
Yes, Sylvain?
I have a quick question. Thanks for the demo. I tested it last week actually, but I wasn't able to monitor, so glad to see how we could do it.
I see that we can offer favorite tables. Could this perhaps impact performance? Well, I had tested it at Fox.
It has never been conclusive. That, I think, is an option you can add. The interest of this kind of option is to be able to the Big IR engine. Only load these tables from this dataset to avoid being cluttered, to avoid filling memory with other queries. We never really managed to use it much at Fox, as we only created instances without a fine tuner, and we were already super happy.
It does something quite smart, actually. BigQuery by default will put your most used tables in RAM. It makes a pretty clever calculation on its own.
Do you mean that BigQuery is smarter than us?
He's doing some stats. I don't know if there are other questions about the Big IR engine.
Yes, I had a question. I wanted to know, is there caching of BigQuery queries? Is there caching with the Big IR engine or not? A very good question. There is no cache.
No cache. It is not cache. It is always up to date.
Okay, thank you.
The cache, in any case, you have seen, it's a bit of a mystical thing for those who use BigQuery. The cache, you often see it when you use GCP or from the same client, but there is no cache between two different clients. For example, even though it's the same thing, generally never rely too much on the BigQuery cache. It's often better to put a cache in front if you want that kind of behavior, but don't use the BigQuery cache. It's not very usable.
There you go.
Yes, let's move on.
Go ahead.
Slack alerting, I'll let you talk about it, maybe, Nico.
Yes, that's something we had at Fox, sir. It was developed for us. Basically,
if you use GCP, there isn't really a budget alerting system, meaning there is one, but it's over a long period of time. It's a little different.
Personally, it has already happened to me to get an alert, but it was after a few days per week. And you have the most beautiful eyes to cry. What Big Blue does is it updates every hour. So it's tables. We were talking about information security. It will create tables. We will come back to the question right after. That way I finish, but we will save that for the cache. The alerting then. Big Blue will update every hour, and at the end of each update, it will perform anomaly detection tests, cost anomalies. So when you have services that usually consume a certain amount of euros or dollars per hour, if suddenly it goes up, it will send you an alert. And if it's in Slack, well, you will be notified immediately. That's rather essential because already when you do it,
you're not the only one who sees it when it's in Slack. The whole team can see it.
It activates a team discussion to see issues with services, with problematic requests. As a result, it starts a discussion. Wait, is it the right clustering? Is it the right partitioning? Should the data be structured like this? And it increases the skills of the team. There is a second alert that is set up, which is a budget we had put in place with Benoit for Fox, where I had asked for a maximum of $30 per day per person. As soon as this threshold was exceeded per day, the person's name popped up in Slack just to ask the question of, what are you doing? Because it amounts to $30 per day per person. So also we had about 100 people at Fox who were doing BigQuery. So these were immediately quite significant amounts. Well, what we observed the month after activating this thing was that the average cost per person on BigQuery decreased by 25%. And it's not that they worked less, but they worked better. So it supports an increase in the team's skills. It's super important. And if Slack is a central tool for you, then it becomes super natural. So this is really something to do. In Big Blue, you click on add to Slack, and you will start getting notifications popping up directly in the channel. Great. It seems simple. For your information, I also found a hack on that. I think we had too large expenses on Metabase because there were emails going through. There are also quotas we can set up on GCP at the level of service. No, it's not even IAM. It's in the cost rates. You can set a quota on the BigQuery APIs to set a maximum number of gigabytes used, which then cuts off. However, it cuts off for, well, all the time, but at least it prevents when there was an initiator who had purged way too many things. At least it cuts off. And I am notified I can do the thing. I set a hard limit, which is still quite large relative to our daily costs, but it's a daily quota. So you can see a bit that.
That's true.
The problem is that it cuts off, but it's roughly the same thing.
It's a day in advance, this mechanism. Maybe it should be added because even if he's alerted and the guy keeps saying, well, I really want to see what's in this table 50 times, well.
It's clear.
It happened to quite a few people, I think. We've all had the problem at some point.
A quick word about storage. It doesn't seem like much because storage doesn't actually cost much, but when you have a lot of data, as most of you probably do, I imagine, it starts to result in big bills of thousands of euros every month. And in this storage, we realize there are a lot of tables that are not used at all. For example, 6 months. What do we call not used at Big Blue? That is to say, they are, of course, not modified. There are no new writings, but they are not used anywhere. They are referenced in no query, in no project. And we suggest on the tool, I don't know if you want to show, Nico, to just see all these tables and give you a list of those that are not used at all. From there, you can decide whether to delete them or not. And that's an immediate saving on bills because once they are deleted, they cost nothing. Of course, we don't delete them from our tool. I advise you to ensure that these tables are indeed no longer used and will not be used in the future, but
it's an immediate quick win, you know.
And so here it's, if you see the breakdown of your storage, there's the whole logical cycle part, which we'll talk about a little later, but that's mainly it. Here you have the tables that are used. Here, for example, it's 57,000 tables. And those that are not used, so not used for 6 months, are these with the cost that the storage represents. You can download the table list here. Benoit is right. Don't delete it like that. A good trick we used at Fox was to rename. You test, see if everyone screams, and you'll see if it was really not being used. And there you go. Maybe something interesting about storage is this little graph that shows the distribution of costs per month. The cost of storage per month. And this is the last month of table usage. It means that this is quite a good curve because most of the tables that are stored, they are stored, they were used at least 1 month, a little less, at least 2 months, etc., 3 months. You understand the principle. What this kind of graph allows you to identify is that if there was a peak here, let's say in December 2023, then it would mean there is storage that still costs a bit.
Or even a lot, even though it hasn't been used a single time in a year.
So here it's worth taking a look, doing a good spring cleaning, especially before setting up automatic data expiration systems, etc.
I'll let you continue with the building model.
That's another thing. It's a feature that came out last summer, the summer before last, which is quite simple. As I was saying, it's fake data. So it's not real, it's data sets. At the level of a data set, there is an option available on BigQuery, which is to choose the billing model. There are 2 modes. The default mode, which is the historical mode, which they call logical, but is actually uncompressed, and the physical mode, which is compressed. That is just the billing model, meaning that on BigQuery, everything is compressed. There's no issue. However, the way they will calculate what it costs in storage in the end, they will say either they take the total of the tables, the total bytes of the tables uncompressed, here in logical times the pricing, or the total of the compressed tables times the pricing of the physical. That makes a big difference. The difference is that, for example, this data set here costs $240 per month, uncompressed. It would cost $193 less if we use the physical pricing. It's really worth it. Why is it more interesting in this way? It's because the nature of the tables in this data set compresses well. It's not always true. Sometimes it's better to be uncompressed.
Because there, in your example, I see that it's always better to switch to physical, but actually sometimes...
It's not said, it's not said. I might have the opposite as well. I would need to see. There I have a few, but these are very small amounts. You see, it can happen. It can happen that we sometimes say,
we must not put everything in physical mode in a haphazard way because we're not sure we'll gain from it.
And especially in addition, keep in mind that a dataset service, meaning the moment you create it when there are 0 tables, and a year later when there are many tables maybe, already this person will be able to keep it beforehand to see if it needs changing. Maybe it needs to be changed several times, and above all, it's very easy. There's the link. I'm not going to go there, but you will arrive at the BigQuery console at the dataset level. It's an option. You check to set it to physical, you uncheck to switch back to logical, and you can do it 10 times a day if you want. So there is really 0 risk. However, if you do it starting tomorrow, you will not be billed in the same way. So these are really ultra quick actions to implement that can, depending on your storage situation, save you a lot of money. That concerns a lot of companies with large storage. Fox, we almost had 25,000 euros of storage per month.
It was worth it.
Simon, yeah?
If it's related to the nature of the tables, whether they compress or don't compress well, honestly, for the majority of our tables, it's better to go for physical, unless we do a big ugly JSON that compresses less well, I suppose, but otherwise most things compress well, right?
It depends on the compression algorithm, and that's a bit of a black box. The only thing we can do is, because you see this information, you have it in the information schema, that's it, the table. And you have 2 values, which are the logical values and the physical value.
Ah, yes, so you just need to know if, and handle the case of what its values in physical.
Exactly. Then I made version 3 because there's also hot storage and cold storage, but that's another story. Anyway, this thing is really a good lever to be able to make money, very simply. And 0 risk, it's not even about deleted tables. You can change it tomorrow if you want. So that's very cool.
So cool. I'll take over to move on to the next part.
I think we've caught up, which is not bad.
Job labels. It's quite simple. Basically, what is a label? On each BigQuery job, you can associate one or more labels that will allow you to batch queries via this label. Basically, it's more or less like adding a sort of business concept to queries, or a job, a team, a client, etc., to be able to track a whole bunch of queries and see how much they cost, if they are efficient, etc. Basically, it's especially when we get into the Big Blue console. We will be able to track these queries more precisely and by business concept.
What is practical above all is that most tools like Airflow, dbTL, Looker, they automatically create these labels. And since they are extremely query intensive,
it will allow us to quickly see if there are execution problems or if everything is going well, etc. What are the very expensive projects? There is someone in a team who created a completely crazy dashboard that is exploding. We can immediately identify thanks to these labels. Maybe you can show a graph that shows that, Nico. I don't know if you have it.
Yes, wait, Tech, I'll take over.
1, 2.
That's the little graph from earlier. You can see that on the tabs we have tag ID, task ID, run ID. Those are labels, professions. That is to say, when you click here, I might put it in to be simpler cost. I will put. If you use Airflow, do you know what a tag is? Basically, it's a series of things to process. It's like a small ETL. You have the name. We put it in place at Fox because it was super convenient. And what it offers is, one, to have an additional dimension to break down your data, and especially to also be able to use it for filtering. You take one of the values you use and you use it as a filter. You can go very far in terms of data analysis. And what it has brought, let's say at Fox, is autonomy to the teams. That is to say, there's really this idea that here, well, it could be the Looker dashboards to say, okay, we are responsible for that and that. We know exactly the cost it represents, the evolution of costs, or the constraints, the requests that are associated, the optimizations to be made in terms of clustering, partitioning, etc. And it especially gives them visibility that if you don't have this kind of tool on BigQuery, you can do it. It's still a real hassle to get this kind of granularity in terms of cost analysis and performance. And so, as Bruno also said, it's not just the autonomy of the teams. It's also having a business perspective on what a client costs. If, for example, your business is to create dashboards for clients where each has their own dashboard, you might find it here. So it's really an interesting thing, especially since these tables, as we told you at the beginning, are stored with you. It's in your data set. So if tomorrow you want to create a dashboard that centralizes a client's costs and you add the data retrieved from BigQuery, which are business data, you could use it to create your ultimate dashboard to know how much a client costs. Lots of possibilities.
I am paraphrasing what you just said. I don't know if it was super clear. Basically, Big Blue read what's in the ISO schema format to produce this data. But this data we will request writing in a single data set that is probably called Big Blue, but it's with you. The data is with you. So you can query all these graphs we offer here. You can query them yourself and offer the data sets to your finance teams or to
your clients, you know.
And I'll take over to continue on the last point.
Simon, do you have a question? Normally, by default, DBT and Airflow, do they add a lot of labels or just one label, Airflow and DBT? Is it up to us to add, well, this DAG, it's this DAG, or it's this DBT action? Or does DBT go as far as saying, here, I created this table, there, I did this? And so it would allow us to see all our DBT pipeline deconstructed like that. So we saw it with one of our users recently. There are a few, but it wasn't enough. So he preferred to add a layer himself, some more business-related key values that, is it directly on DBT? On DBT, yes, it was on DBT. It's like creating a tagging plan, a web application somewhere. It's really, you have a map of your data. Where is it used? How? By whom?
the big piece. So that one, we included it. We won't go too much into detail because it's a big thing. I will still
show cool stuff. First, the reservation. How does BigQuery work?
We'll start with the basics. You make a query. The principle is that it will parallelize lots of small computations, which it calls slots, that you must have already heard, particularly regarding limits or things like that. So a slot, then there is a radius, and it gives you the result of your query. That's how BigQuery works. When you use the default system, which is the on-demand system, it will charge you for the volume scanned by each compute unit, scanned in total, and it will tell you, there you go, you have scanned 1 terabyte, and, well, that will cost $6.25, proportional to the others. That's what it does. And it offers a second mode, which is not calculated on the volume scanned, but on the time of these compute units, the time these small slots spend working. So imagine you have a query for 1 minute. There are 10 slots that will operate. Well, it will be 10 times 1 minute of slot time.
He takes this time and charges you the pricing, which is like, I think it's between 4 and 6 cents
per hour per slot. There you go. So we can set a price. So how do you know how long it will take? Actually, when you are in the console, you know, you have the prediction of what it will scan at the top right before doing it. That's the dry run that allows you to do this, which tells you you're going to scan 1 tera, you know, before pressing that it's going to cost 1 tera, so $6.
It does not tell you how long it will last in slot time because, in fact, it cannot know.
Which means that overall, if we simplify the thing, when you have rather complex queries, when they take time to be done, they will be cheaper on the on-demand, whereas when you have requests that can scan as many terabytes as you want, but are quite short to execute, it might be more interesting to do them in slot reservations. So it's the same way of working as BigQuery. The only difference is that the price calculation will switch from an on-demand model to reservations. That's how it works.
It's quite complicated, especially because he doesn't tell you how long it takes.
Evaluate if a query would be better off going on demand or towards slot reservation in advance.
So if I understand correctly, it's at the query level at execution time that you have to choose whether you say A or B, basically left or right, on demand or reservation. And you hope that one or the other will cost you less. Is that it?
Exactly. And as I was saying earlier, we can't know in advance if we have never executed this query, except that when you execute a query, in the end, BigQuery will provide you with this information on scanned volume, but also on slot time. That is in the metadata that you can easily find. It's also in the schema information. And what we did to make it easier to use, for having a tool to use slot reservations, in fact, we're going to make an API that will tell you use on demand or use reservations. How does it work? It's that at the end, the first time we pass a query into the system, we only send the hash. We don't receive the query. It's just to identify it. We say, okay, it passed, it's on demand. We don't know it, no problem. By default, it's on demand. The second time, since we stored the time slots and the scanned volumes, we can say the last time this query went through, it was more advantageous in reservation. We'll tell you, you go on the reservation project. Instead of going on A, you go on B. There you go. And that's what we implemented at Fox. I know it works well. But when you don't have a system nearby, it's not very obvious.
We made a tutorial. We will also put links in the chat
on that. But what you need to understand is that from what we have observed, most of the time, the pipelines we have, your workloads, what they do, is that often it's the same processes being executed. So it's either every day or every week. It depends on what you are doing, but overall it's the same with the same results. And actually this system of processes, well, every time we look in a schema course, we are able to say that these requests, they cost that because they were on demand. But if they had been reserved, they would have cost that price. So there, in the example, you have the thing that says this batch of requests, there are 5,000 of them. Would have cost $6,000 on demand, but it costs $3,000 when booked. Reservations are like you pay for the reservation. You don't pay for the request if it fits within it. It's simple. So we change a bit. It's less easy than on demand, but it's an advanced usage that we've simplified as much as possible with our API. I'll put the little link to the article so you can have a look. And honestly, it's not just talk. You can implement autoscaling reservation in 10 minutes. After that, you have to put it in your project. That takes a bit longer, but overall, it is completely doable. And we know that it works, and I will share a screen with you, by the way.
This one is very good. All right, I'm taking over.
This is the screen we use for the
reservations. So the analysis of reservations. Here you have the usage of reservations in red. That's the cost of the reservation. In blue, it's how much we use the reservation. That's always a subject. The first project, this one, I don't remember anymore. There, it's an autoscaling project. This one, in reservation cost, it costs $6,000. In cost, the cost that would have been on demand for the emails that went through this project is 10,500. That means it halved the cost of the emails. Notice there in the new clients we have, it's often where there is the biggest leverage for gains. That's why the tutorial we made it to facilitate this ability to say you need to go on this project in event or this project in reservation is super important, and that can really greatly reduce the bill. A bit more work than the other points, but it's still not bad.
What we see in your graph is that you always pay more in reservation than the number of queries you'll make in it. So the point is to try to maximize this blue curve so it aligns as closely as possible with this red curve. Otherwise, you'll gradually end up paying for reservations you don't use.
Exactly.
If you have reservations, you need to push the queries into them.
Exactly.
That's what you mean by auto-scaling. It goes up, it goes down.
Yeah, exactly. By the way, you'll see in the tutorial, it's very simple. You say, you choose the size of the reservation and you say from 0 to, I don't know, 200 slots. And so by definition, it will be 0. So as long as you don't send any requests in, it costs 0, so no worries. And when you start sending requests, it will go up, then it will go down. Where you lose money, so to speak, is if you send just one request that, for example, uses 30 slots. It's important to know that auto-scaling only works by incrementing 50 slots by 50 slots. So it will increase by 50 the time of the request. Then once you are finished, after 30 seconds, it will drop back to 0, no problem. But during this time, those 20 slots that it will charge you for are not used. And so in a way, it's kind of this loss. That's why the blue is never right next to the red either.
So that's what you need to see.
And another small thing, due to this constraint of slots, which cannot be below 50 when instantiated, it means that you need to have a relatively significant BigQuery consumption. That is to say, we have analysis that allow us to see this, the slot time, but finally, the average number of shots used. But if you don't even have 50 slots minimum that are used on your project, it's not worth implementing this kind of solution. It's already when you have quite a high usage.
Super clear. I think that's all. Is that?
Do you have any questions?
Was it digestible? Yes, Jean-Baptiste.
Hello. I had a question earlier in the presentation about the cache. You were saying, Nicolas, clearly the BigQuery cache, well, the site was not usable.
You can, but finally, so as I tell you, what we did at Fox was that we tried at one point to use
like a cache server, as one might expect, but it was very unusable for us because, in fact, it was a bit mystical. Sometimes for the same query, just because we had different clients, it would not bring back the cache and would charge us. And so, as a result, every time, in any case, we preferred to set up our own cache right in front, like a ready, something like that, which was placed in front of BigQuery.
Okay. And so you were using the query as the cache key, I imagine?
A hash, yeah.
A hash of the query then. Because on the BigQuery pages, there is indeed a list of prerequisites to use the cache, specifically queries that must be deterministic. So no dead time function. Well, I don't even know anymore. Did you look at all that before?
That's it. That's why in the end, we didn't use it. We didn't rely on it.
There were too many constraints.
even if you give it a current date and make the request 5 times a day, so your current date is supposed to be the same, it will still say, I don't really know how you're going to use it, so I don't use the cache. However, if you put a cache in front, your current date, if it's today, will always be the same date. So it will, finally, if you put the cache in front, you will see that it's the same query. But if you use the query that you sent to BigQuery, it's current date. It will use a function, and it will not use the cache, I believe.
And especially since there is a chance that as soon as you modify one of the tables behind the query, it cancels everything.
Oh, yes. If the data is updated, indeed.
It depends on how it works for you, but if you have ingestion on a table and it does, at some point you have a dashboard pointing to it and that table is all being updated, well,
That means it makes the cache usable in streaming cases.
You use a streaming API, however, when you do daily batching.
you see, for us, for example, at Fox, we had a process that we delivered, let's say, once a day. It's not quite true, but for an entire day, we had the same tables that did not change on the final product we had, where we did analysis. It is true that in that case, it could work. But even there, we prefer to have a cache further upstream on the graphs themselves. So it really depends on what you're doing.
Okay.
There is something about, it's the top 6 things that happened. I think you noticed that at no point did we talk about the things that are the classic optimizations we imagine with BigQuery, which are partitioning and clustering and the architecture of data in general. That could be another webinar. But why did we do this? Because these optimizations, which are true foundational optimizations, architecture and SADA, are something that takes time. You say at Fox, we did that all year. There are plenty. There are many. What we gave you is, Lever, these are things that are not risky, that are easy to do without being an expert in partitioning or clustering, and that really impact performance. I'm talking about big engine, or on cost in general, which change the situation a bit. And you see the label part, which is not really a money gain, but that's a prerequisite, I think, before doing other optimizations. That is to say, once you have a good tagging plan for your data, how we use them, etc., you'll be able to easily choose where to start, with which project, which service, which query. And there, you'll indeed have a lot to do on partitioning, clustering, or sometimes both. We did a lot of tests, because it wasn't always straightforward. There's plenty to do, but start with the labeling part. That's really useful.
Does Big Blue allow you, I don't know if it's the right answer, but does Big Blue allow you to drill down to the query?
Yes, completely. We can go up to the request and
we will tell you, for example, you are using this table in this query. It is partitioned with this field, or you are not using this field. We will provide you with the information. Then it's up to you to decide if that's normal or not. We will even offer you views on tables. Sorry, we're going a bit over, but we will offer you views on tables. We will tell you this table is called 5,000 times with this particular where, with these filter fields, 2,000 times with these fields, etc. And yet it is clustered like this. Maybe it would be worth it to redo a version of this table with different clustering, different partitioning, and then modify the queries to hit this new table in order to optimize the SQL volume.
There you go. Lots of things that are possible.
There you go.
5:47. That's not so bad, Nicholas.
We're fine.
Is there, for those who want to stay, if you want, we can spend a little more time with Nicolas. We can stay. And then thank you very much for coming. This is the first webinar for Big Blue, so we're very happy. Feel free to contact us, and I'll provide more information, etc. And for those who want to stay, we're available if they have any more questions or anything else, etc.
And by the way,